All right, let's go ahead and get started. First, let me thank you all for taking time out of your busy day to be here with us. We have a really great turnout. My name is Diana Borns. I'm the president of Ascendo, and I will be your moderator today. Today's topic, software testing secrets for faster delivery and higher quality, will be presented by Dave Todaro, CEO of Ascendo. We have quite a bit of content for you today. The presentation portion will probably last just about a full hour, and we have an additional 30 minutes for a live Q&A. I've enabled the Q&A feature located in the Zoom controls, and go ahead at any point and add a question into the Q&A window. And you can also click on the like button to upvote your favorite ones. I realize that you may need to drop off before we completely wrap up, but don't worry, we will continue the recording through to the very end of the live Q&A, and we will be sure to get a link to the recording and slide deck out to you. So let me just take a moment to introduce Ascendal for those of you who don't know us. Ascendal is a leader in custom software development. We partner with companies as their full service development team to create mobile and web applications to drive business goals. We offer web, app, and platform development along with product strategy, product design, and agile training services. Here are just a few of our clients. As you can see, we work with a wide variety, all shapes and sizes, from the early stage startup to some of the largest companies in the world. And we are recognized experts in our field. We love to share our many years of experience by teaching others. And we wrote the book. Dave spent 2 years to capture everything we know about Agile development, and in 2019 published the 500-page Epic Guide to Agile. Let's get on to introduce our presenter. Our presenter for today is Dave Todaro, CEO of Ascendo. For the last 35 years, Dave has been a technology leader involved in all aspects of product vision, software engineering, and entrepreneurship. Dave, let me go ahead and hand the mic over to you.
Thank you, Di. I appreciate it. And everyone, thank you so much for taking time out of what I'm sure is a busy day and a busy week. And I hopefully will give you guys some good takeaways today. One of my favorite topics, which is software quality, sometimes elusive, takes quite a few pieces coming together to drive quality as high as possible. And the good news is that when you do drive quality high, you can actually accelerate and move faster. So that's pretty exciting. Before I dive in, let's go ahead and take a look at the poll results. Let me go ahead and share that. We can see what we see here. So it looks like everyone is certainly doing manual testing. That's the good old standby, and employing lots of other things here. Let's see. So other top results, user stories and acceptance criteria. That's great. As I'll talk about, quality really starts at the very beginning, making sure that you have the right vision. The most expensive bug you can introduce is spending all kinds of time building something, but it's the wrong something. So if you get the requirements wrong, that's really not going to help you out. Automated unit tests, that's great, and automated integration UI testing. Fixing bugs before writing new code, that looks a little deficient. I'll talk a bit more about why that's important. So fantastic. So I'll go ahead and close my window here. I think you can close that. You can look at the poll results again at any time. But let's dive in first. It may sound like a little bit of a silly question, but why is quality important? I think we all intuitively know that if we have a really bad product, no one's going to use it, right? The phone will be ringing off the hook in our support team, and certainly no one's going to refer us to somebody else. But really what it boils down to is a heck of a lot of money. And I was a little surprised by this. A report I found estimated, and there's actually a link at the bottom here when you guys get the slides, you can read it yourself. $2.8 trillion in 2018 was attributed to low quality for all these kinds of different reasons. That's a hell of a lot of money that people are leaving on the table. So this is a super important topic. It took me many, many, many years to figure out how to do quality right. Way back when, in my early days, I would ship a product after testing it and testing it and testing it and testing it manually for about 2 months. We didn't have the level of automation back then that we do today. 2 months of testing, and inevitably we'd ship it, and 4 hours later, someone would call the support line and say, "Hey, I found this bug. And by the way, it's not some weird bug. It's what I do every day." It just happened to be what they do in the software wasn't the one scenario that we happened to test, and we missed it. But we looked really stupid because they found it in a matter of, it could have been even a matter of minutes. So if you weren't convinced, it's worth the investment. And that's really important because software quality doesn't come for free. There is a real cost to baking in quality. Those of you who have been in software for a while probably understand this implicitly, but a lot of times we look at some of the things we need to do to drive quality into software, and we kind of look at it and say, well, that seems like it costs a lot of money. The good news is that it's an investment, not an expense, and it does pay off. And just to illustrate that, this is a pretty classic chart from the waterfall days. What this talks about is the sort of traditional waterfall phase where a defect or a bug is introduced, and then the phase where it's actually detected and corrected. And you can see that over time, the key takeaway here is that the longer the bug sits in there, the more expensive it is to fix. And the worst possible bug, as I alluded to earlier, is if I introduce something in the requirements phase. Those of us who are using Agile, if I write the user story and I'm actually writing it wrong, and it's not going to result in what the user wants, and then that gets all the way out into users' hands and is detected at that point, it costs a heck of a lot of money. In fact, it can be 50 to 200 times the cost versus fixing it when it was first introduced. So this is just another illustration of just how important it is to address software quality. And the other really big key takeaway is we need to accelerate quality. So we need to get quality accelerated earlier in the process and eliminate those bugs, because a lot of that cost isn't just the fixing of the bug. It's if those bugs kind of stay in there for a while, what it does is it slows the whole development process down. So if we do address quality early, we're actually going to speed up. We're going to speed our teams up by accelerating that quality. And this is sort of the opposite of the traditional waterfall approach, which is we do all kinds of stuff for a long time, and then we work on quality, right? We get it kind of all built, and then we start testing it and fixing it. That's sort of the polar opposite of what we want to do. So today, with an Agile approach, we can bring those quality processes earlier into each of our sprints, drive that quality to a potentially shippable state, and keep it there all the time. And that's actually the really hard part. It's not as hard to build in quality if you've got a lot of time. Back when we were doing the test and fix process for 2 months in the olden days. But today, being able to do both the design, coding, testing, and fixing and acceptance within the confines of one, say, 2-week sprint, that actually takes quite a bit of not only technique in terms of process, but also technique in terms of the software engineering tools and things that we use. So this really is the quality standard that we want to get to, which is, again, we have this concept of a potentially shippable product increment. So at the end of each sprint, what that really means is that we should be able to, at the product owner's saying, go, I want that in production, we should be able to actually get it into production and into end users' hands within the confines of one additional sprint. So if you think about it a little bit, if I have to start testing at the end of the sprint when that product owner says go, and then do all kinds of very heavy lifting, there's no possible way we can do that. So, and just to be clear, this standard is extraordinarily difficult to attain, but when you do, it's a game changer. Because what it does is it gives not only a heck of a lot of flexibility to the business, because the business knows that via the product owner, I can say at any sprint review, I want that, and know that it's going to be in production in 2 weeks. It also dramatically reduces risk. because if I don't really know how long it's going to take to get in production, if we take a step back and think about our schedule, my schedule is useless, right? Because if it takes us between 2 and 8 weeks to actually get something out into users' hands, well, I have no sort of precision. Software schedules aren't overly precise. We like to say that plus or minus 10% is pretty good, but I can introduce a plus or minus sort of 2-week to 8-week question mark in my process. So how do we do this? First of all, a great quote from a brilliant philosopher: quality is not an act, it is a habit. And that really ties into this idea that each sprint, we're going to drive that product to a potentially shippable state. And we can't kind of do it just once in a while. We need to do it all of the time. So channeling some Stephen Covey here, it's the 7 habits of highly effective teams. What are the things that the most effective teams do to drive quality high? Well, the first thing I sort of outlined earlier, right? The idea that right from the very beginning, I need to create a clear vision. So using user stories and acceptance criteria, being able to capture at a high level, what is it that we're going to build? Next is taking those acceptance criteria and expanding them. And I'll talk a little bit more about this, expanding them into what we call acceptance tests. This is also called test scenarios, business-driven development, or behavior-driven development, rather. And what we find that this does is helps to visualize at an even higher level of detail what is it that we want when the software is working correctly. Next is automated unit testing and continuous integration. That is running those automated unit tests all the time. And I'll talk more about that. Peer code reviews is a really big one. This has been shown to detect quite a few bugs that otherwise wouldn't have been detected. So another key aspect of a good quality discipline. Testing manually, most of you are doing that. Within team test environments that support automated deployment. Now, the automated deployment piece is critical because if it takes me 4 hours of manual work to deploy the latest code, inevitably that means I'm going to wait, right? Because that's really painful. If it takes me 4 hours, I'm not going to be diving into every single code change as the team is producing it. And being able to test often is a super important benefit. And then finally, this is the one that very few of you are doing, is to fix bugs before writing new code. And this ties into the potentially shippable state of the product. If there is any bug in the product that I know about that I've decided that I need to fix, I can't ship the product, which means that I'm breaking that rule, which also means that my schedule is also completely useless. Because as we know, the time to fix a bug, and I've talked tongue in cheek with various stakeholders when they say, well, how long is it going to take to fix that bug? And I say 5 minutes to 6 weeks. And they kind of look at me like, what the heck are you talking about? The point is, and I was being a little bit cute, the point is that bugs are almost impossible to estimate very reliably. Once you get in there and start unpacking what's going on, you might find there's all kinds of different things happening under the covers. So if you have bugs sitting in your product backlog, by definition, your schedule is completely useless, because I don't know what those bugs mean. I don't know if those 10 bugs are 10 minutes each, a day each, 2 days each. So that's super important to get those bugs fixed. The other thing I want to do is leverage automated integration tests. And this is going to let me make sure my components work when they're all put together. And I just realized there's a slight layout issue on this slide. I apologize for that. So it's key to have a comprehensive quality strategy where all of these things work together. So what I am focusing on today is testing, which is part of the overarching software strategy. Again, all of those pieces are super important to incorporate, but testing is the piece that we're focusing on today. So I'm going to talk about a few different things. First of all, the testing strategy, making sure I understand what it is we're going to test and how we're going to test it, planning my tests, manual testing. Again, almost everyone is doing that today. It's still super important. We're not going to get rid of manual testing. What we're going to do is we're going to minimize manual testing. Automated unit tests, that is being able to write code that exercises other code right down in the guts of the software. And then automated integration tests, which is allowing us to mimic sort of how the product is being used when all the components are stitched together. So first, let's talk a little bit about strategy. So manual testing is awesome, but it comes with a trade-off. And it ties back into this concept, which you'll hear me say over and over and over again, which is we need to get that product increment, whatever we've built to date, we need to drive it to a potentially shippable state within each of those 2-week sprints. A sprint can be 1 week to a calendar month. Most teams use 2 weeks. So at the beginning, if I do have a 2-week sprint, I do some coding and then I do some testing. Great, it all fits. I can get it done. However, then time goes on and now the product has gotten a little bit bigger. So now I do a little bit less coding, and then now it's going to take me more and more time to do all of that required manual testing. Because remember, the thing with software is that I touch one thing over here, it might break this other thing way over here. And I don't know if I've broken it unless it's tested somehow. And that's one of the traps of software, assuming that I only need to test the new stuff that we've coded and not the old stuff. And those who have been in this business for a while will realize you may run into that same problem that we did, where we missed one part of the old stuff, which might have been coded 2 years before. Somehow we broke it and we didn't detect it. So here's the problem. We get to this tipping point where we have our 2-week sprint, we have even less coding, and then the testing doesn't fit. We can't actually test the entire product. So what inevitably happens here are a couple of different things, a couple of different smells that can rear their head. One is, well, let's just start testing a little bit less of the product. Or it could be, well, we'll test just the new stuff during this sprint. And then when we're ready to release, we'll go ahead and do regression testing. We'll test all the old stuff. Well, then you have the same problem. You're just kicking the can down the road, right? Because it could take you, as the product grows, 6 to 8 weeks to do all of that manual regression testing. Or what may happen is we say, I'm sure it works. We'll just go ahead and stop testing the whole thing. And that is what gets you into a lot of trouble. And then you're digging yourself into a hole. So if we rely 100% on manual testing, my contention is it's impossible to have an agile software development process. The only possibility is to have a waterfall process with all of the costs and downsides that come with it. So how do we solve it? Test automation. So if we can't do everything manually in a short enough time, then we need to automate. So we need to be able to use the computer and be able to leverage code and technology to exercise our product and make sure it all still works. And there's 2 main areas of automated testing. One is automated unit testing, and the other is automated integration testing. And I'll talk about each of these, but the short version is automated unit testing is focused on individual components. If you think about the software product as individual Lego pieces, unit testing is focusing on each one of those Lego pieces and making sure it's correct. So at the risk of dramatically stretching the analogy, I'm going to look at that Lego piece, make sure all the little dimples are lined up so it's going to fit into the other Lego piece, make sure the bottom is such that another Lego piece will fit into it underneath, etc. Whereas automated integration testing is, I'm going to put all those Lego pieces together. I've built the car or the airplane with my Legos, and now I'm actually going to test those pieces all put together to make sure they do in fact work. So that's a very high level overview of those 2 pieces. What we've discovered over the years is that there's multiple pieces that need to work together in order to make it so that you can both create the test automation and maintain it. So if we look at the scenarios in the software, and we typically talk about scenarios in an individual product, It's not as much about testing every single line of code as it is every path through that code. So if I go down and I encounter a fork, I'm going to go one direction and then I'm going to go another direction in another fork. I need to test both of those forks in the road, so to speak. But there might be some code that's actually exercised more than once, one for each of those different code paths. So sometimes you fall into a trap of saying, well, I've got 80% of my code tested. I'm sure we're good. Where really what you want to do is instead think about, I want 100% of the code paths to be tested. So if I think about the scenarios, really the foundation of testing is automated unit testing. And I realize that in some cases, particularly if you have a legacy product, this might be challenging. The ability to unit test is largely dependent upon the architecture of the software, how it was actually designed, how those different components are actually fit together. And sometimes when you're dealing with legacy code, it simply can't be tested using unit tests. But there's some things that you can do to add unit tests, particularly if you're writing new code. The other piece of the puzzle is automated integration tests. And you'll notice this is dramatically smaller. The reason is that twofold. One, if you try to test everything using automated integration tests, you're going to repeat a lot of the work of the unit tests because those are sort of forming the foundation of the code, again, inside those individual components, the individual Lego pieces. So I don't need to exercise all of the different paths in the code through integration tests. I need to focus on the integration, meaning where those components touch each other, I need to make sure that those interactions are all working. So the second drawback to trying to cover all of the scenarios with automated integration tests is they tend to be more expensive to build and more expensive to maintain. And they also tend to be a little bit unreliable. You can get false positives and false negatives with integration tests. The short version is that they're a little bit brittle. They're not quite as reliable as unit tests. They also take a little bit longer to run. Now, in the middle, we look at manual testing. And you can see there's more scenarios that we do with manual testing. So you might scratch your head and say, well, wait a minute, I thought we were trying to minimize manual testing. Well, we do because it's based on the frequency of the manual testing. The automated testing, because it's less expensive, meaning I don't need a human to be able to sit there at the keyboard with the mouse and do all this work, I can actually run this automation multiple times a day, and it costs me very little. If my integration tests really took a long time to run, maybe I do it nightly, but certainly I'm not waiting weeks and weeks to do it. In contrast, the manual testing is mostly around when the functionality is initially implemented. And then we typically do a more abbreviated test as we go along. So as we get closer and closer to production, we'll actually reduce the amount of manual testing that we're doing and sort of shifting more into a sanity check, or what's sometimes called a smoke test. Back from the days when you turned on the power switch to the room full of computers and you saw if any smoke came out anywhere. So we just want to make sure that the product generally works, but we're relying heavily on the automation to make sure that everything that we've built is actually working together. So let's talk about how we actually plan our testing. So I mentioned earlier, we use what we call acceptance tests. And this is a scenario-based testing approach. And another way it's referred to is specification by example. And this is super powerful because instead of getting into an abstract, it should kind of do this when this happens, we're going to be talking about specific scenarios. And I'll show you how that works in a minute. I like it because it allows what I call pre-visualizing the intended behavior of the application. I like to watch documentaries about how movies are made. And if you're watching a movie about or documentary about some action-based movie, they'll show you how they storyboard the movie. And it's not just storyboards, which are kind of the traditional pieces of paper on the wall. They'll actually do animations, very low quality, low resolution animations on the computer to show how these scenes might look, complete with, here's what the camera angles are going to look like. Here's a little bit of a hint of what the special effects might look like. So they do a lot of pre-visualization. Why do they do that? Because once they get on scene, on location, everything becomes dramatically more expensive. They're pulling permits to shoot in the middle of the night. They have a certain number of days. The on-screen talent is very expensive. They've got 150 people or whatever it might be on set. They've got 200 extras that they've brought in. So they better make damn sure that by the time they get there, they have a plan and they know what they're doing. We can leverage that same technique for our products because it gets really expensive once I start writing code and I drive that code to a potentially shippable state of quality. The format that we use is called behavior-driven development, or BDD, and it has a specific format which is given, when, then, and I'll show you an example in a minute. So let's look at this fictitious user story that I might be testing. As an author, I want an indication of misspelled words so I can prevent spelling errors in my document. We're writing the next competitor to Google Docs or Microsoft Word, and this is the spell checker user story with some very basic acceptance criteria. I just want the little wavy red line underneath my words. And then once I fix it, it should go away. Super simple, right? This should be easy to test. Let's see what we might write for an acceptance test. So we like to use a few different parts, just a general summary of what this test is about. Some background, so I don't have to repeat the same sort of setup in every one of my scenarios, and then the individual scenarios. So here's an example of the first one. And now you can see the given, when, then format. Given I am typing a new sentence in my document, when I type the word hello, and I press the space bar, I should see a wavy red line appear under the word. Okay, great, very simple. Now again, this is really easy and a very straightforward example, but it's concrete. It's a specific example with a specific word. If I was building a calculator, I might say, well, I want 2 + 2 = 4. 2 + -1 = 1. I want my specific scenarios, and this is the specification by example. And as it turns out, we as humans tend to react a lot better to this style than something that's more abstract. If I type a word in that's misspelled, I want to see an indication of the misspelling. Well, that's a lot different than this specific example. Now this scenario here, I want to see what happens when I correct it. So I fix the word, I change halal to hello, and I press the space bar, then the wavy red line disappears. So again, super simple example here, but it illustrates the concept. We use this typically during the sprint where we have the user story, and it sits between the user story being introduced in the sprint and the coding to the greatest extent possible. If it's the very first story in the sprint, this is probably happening in parallel with the coding. But we do try to get ahead in the sprint. We try to kind of go down vertically through the sprint backlog and write these acceptance tests in that sprint. And it allows us to expand those acceptance criteria in the user story and visualize or pre-visualize the behavior of the software. This helps not only to form a bridge between those acceptance criteria and the implementation, but it also allows what I call beta testing the acceptance criteria. Sometimes when the team is writing those criteria, it's not until they would go to code it, then they realize, wait a minute, this actually doesn't make sense. Or what about if the user doesn't type in a password and click sign in? Should we do something there? Well, we found, again, this theme of accelerating quality by writing these acceptance tests, by attempting to pre-visualize the software. What it does is it detects those problems before the developers are getting into the coding. And so we can head off those issues early. We can talk to the team, hey guys, the acceptance tests were being written. I just discovered there's a little bit of a hole. Do you think this is a big deal? If so, I can put it on the backlog. If not, is it something we can just add to this sprint? And the exceptional scenarios that I just illustrated, like leaving the password blank, super helpful with those. It also provides some raw material for a few different things, not only the implementation, but also unit tests. We've already thought through a few scenarios, so maybe I can just bring those right into my unit tests. And of course, it forms the basis of manual testing. I'm going to go ahead and execute those scenarios one by one. My integration tests can also be driven by these strategies. And then finally, another thing I really like about acceptance tests is it is, in fact, the as-built behavior of the system. By default, I automatically have documentation of exactly how the behavior works in the product. If I was writing any sort of documentation and the documentation person needed to know how it works, well, here are the acceptance tests. This will tell you exactly what you need to know. So how does that workflow work? I alluded to this a little bit earlier. We like to write the acceptance tests during the sprint and have the developers refer to them. The timing doesn't always quite work out exactly that way, particularly early in the sprint. We do use these tests for the team to what I call certify the product before we hand it over to the product owner. So the team, typically we have a QA person who's both focusing on this writing of the acceptance tests, oftentimes running it, but the entire team, especially toward the end of the sprint, they will typically be running tests as well. We use a subset of those scenarios for integration testing. Again, remembering that sort of strategy with that hierarchy, we have a smaller amount of functionality we're testing with integration tests. And then we're going to use an even smaller set for that manual smoke testing, or kicking the tires to make sure that the product works. And then, as I mentioned, we have that benefit of having the as-built specification. So that's the acceptance tests, really the core driver of not only those manual testing, that manual testing process, but also forming the basis of the automated integration testing. Okay, let's switch gears here a little bit and talk about automated unit tests. And I know that we have a mixture of technical and non-technical people on the call today. Some of this is going to be a little bit technical, but I'll do my best to talk about sort of the implications of how this works. And I'm a big believer in, even if you aren't super technical, being able to just understand what the developers are doing under the covers is super important. Okay, so let's just take a little bit of a look to compare unit testing versus integration testing. I'm not going to read all of this, but just to hit on sort of the high points. Again, it's the Lego building block with the unit testing. We're going to test just that block. I'm not looking at anything else. I'm going to make sure I'm isolating that code that I'm testing from everything else. And each of those tests I can run in any order. There's no dependencies. They're very fast. Typically, even for the largest systems, they're running in minutes, not hours. Early on in the process, that might be running in seconds as opposed to minutes. As the product grows, it might take a few minutes to run them. And that's a critical part of the benefit of unit tests, is that they run fast because they don't have all these different dependencies. And readable, maintainable, trustworthy. I can't underscore enough, unit tests, when done right, is the foundation of your quality strategy. It really is the most important thing. All of these things are important. If I could do only one thing, it would be automated unit testing. If I didn't have time to do automated integration tests, and I didn't even have time to fully test the product manually, still really important. But if I could only pick one, this is what I would pick. And then maybe I just do a little bit of or manual testing rather, just to make sure the product generally works. I certainly would not prioritize automated integration testing over automated unit testing if I had to only pick one. Again, they're all important, but I just want to really hammer on this fact that the foundation of quality is the automated unit testing. I learned the hard way years ago. This was just sort of on the cusp of unit testing becoming more sophisticated and more developed. One of my developers came to me and said, "Hey, there's this unit testing thing. I think we should probably look at using it." And candidly, in hindsight, I didn't pay enough attention to what he was telling me. I spent the next 3.5 years struggling with automated integration testing. We did not have automated unit testing. We attempted to do what you should never do with integration testing, which is test absolutely all of the scenarios. It was a nightmare. So in contrast, integration testing, by definition, 2 or more of those components, I need at least 2 Lego building blocks to put together. And now I'm testing those integrations and communication, making sure it's all working together. A lot of times I can't control some of the resources I'm using. So I might be hitting a web service out hosted by some other company out in the cloud. I don't control that. I might need to do a lot of setup and teardown. So I'm using a database. I'm going to be inserting some data. Well, I need to rip that data back out of there for the next time I run the test, because otherwise I'm going to be creating the same thing again, and it's not going to work because it's saying, hey, I already have this. And the other thing is that it's going to be slow because I'm relying on those high cost resources, as we would say, databases, the cloud, et cetera. They're going to be a lot more running a lot more slowly than those unit tests. And the other thing is, like I said, a lot more effort to maintain. They typically are quite a bit more brittle. These things here are what concern us. And what this results in is a lot of money. They're super expensive to create and maintain integration tests as compared to unit tests. So again, another reason why we want to be really careful to leverage unit tests as our foundation of quality. All right, so a few different pieces of unit testing. First, and I'm not going to get super technical here, dependency injection. Essentially what this allows us to do is pretend that there's a database that this code is going to talk to. Pretend that there's a web service out in the cloud that this code is going to talk to. It allows us to kind of swap in those dependencies by injecting fake versions of those dependencies, which is going to allow our tests to run. We also need the test framework, which is going to be able to execute our tests and report back, did this work, did this not work, etc. Here's a few examples of some technologies you might be familiar with if you are on the technical side of things. The other thing we need is the isolation framework. This and the dependency injection work together to actually fake out the code that I'm testing. Again, making it think there's a real database there, making it think there's a real internet with a real cloud service sitting there, etc. For the technically minded, here's a few examples of those. And then finally, we need the test runner, which works with the test framework to manage and execute those tests and report on the results. Give me a user interface to interact with those tests. And again, here's a few examples. Okay, so I talked a little bit about dependencies. What are all these dependencies that I've been talking about? I mentioned a few of them. External APIs, which could be cloud-based services. They could be APIs inside the firewall, so to speak, that your system needs to talk to other systems within your company's overall suite of products. The database, that's probably the most popular. File system, that's another one. If I'm saving and reading files, I need to isolate that for proper unit testing. This is one that gets a lot of teams, the system clock. We had this one unit test that would fail, but only at a specific time of day. And it seemed to be, it was failing at, let's see, we're on the East Coast, so it was failing at 9 a.m. or 10 a.m., depending on the time of year. And then what we realized was the server that was running the tests is on UTC time. And actually it wasn't noon, it was midnight. So it'd be failing at nighttime. And so midnight UTC on that test server, it would be giving us indeterminate results and would fail sometimes and succeed another time. What we didn't do is we didn't isolate the test from the system clock. So we had that dependency of, well, if it had this date and this time, it would fail. So it's super important to isolate that. And there's quite a few more that goes beyond this list. A few problems that if you don't isolate your tests properly, what happens if that API just happens to be down? Or maybe something has slightly changed. Maybe the authentication I'm using, the username and password I'm using in my test, if I was kind of writing the unit test incorrectly, maybe that's not working. My password expired on my database, and then I can't find that file. Someone moved it. Well, this test depends on that file. And you can see, by the way, These are all things that when you get into the integration testing, these are the issues that you need to deal with. And then I talked about the system clock. And then finally, the big thing, again, that I mentioned is our unit test runs slowly, which we really don't want to have. So there's a few different ways to do unit testing. You can come along after the code's been written and add the unit tests. Most developers find that a test-driven development approach, or TDD, is really beneficial. And how it works is that what I do is I'm going to write a test, and I'm actually writing the test before I'm writing the code. And one of the reasons I do that, there's a few different reasons. One of the reasons is to make sure it actually fails. One of the worst things you can have is a unit test that never fails. And if I don't do this process, I've never proven that the test will in fact fail. And it can introduce some very subtle behaviors because the code might be misbehaving under the covers, but the unit test doesn't do its job because it's not failing and telling me about it. Then I'm going to write just enough code to make the test pass. And then I'm going to do some adjustments to the code as I see fit. I'm going to evolve it. And then I'm going to sort of wash, rinse, repeat. It does take some discipline to do this. When I first learned test-driven development, I think it took me a good solid 2 weeks. I was kind of deliberately focusing on making myself do this process and not skipping steps. What I found is a few different benefits. The first one is the one I just mentioned, that the test will in fact fail, because the test that never fails is useless. The other thing is that I discovered that, and it's not just me, everyone else who does this discovers the same benefits. The design of the code was driven solely based on the desired behavior. So what that means is that I'm not introducing a bunch of other crap that I don't need, and it's all focused very much on what I'm trying to get out of the code. A lot of times us as developers, we tend to kind of get mired down in all kinds of stuff. We can kind of lose the forest for the trees. And this helps us keep at a very high level and write just the code that we need. The other thing it does is it actually forces the developer to execute the code and make sure it's working, at least at that, at that unit component level of scope before committing it. And the other benefit it gives us is it's really easy to step through the code. I'm a little old-fashioned. I like to see each line of my code actually run, so I can see how it's going through the code, and then I can see the other path that's going through the code. I can use my mouse and hover over different variables, and it shows me the value. So if you're writing code traditionally without doing this process and without unit tests, you have to write all of those dependency code to get everything talking, and then you can run the product. This, I can just write the code in this one spot, run it, and then I can move on to the next spot. The other benefit is, just like we have acceptance tests that are documenting the as-built behavior of the product, unit tests document the as-built expectation of the behavior of the individual components in the system at a very fine-grained level. So, which is great, because if you have a new developer who's just coming on the project and they're going to work in this area, the first thing I say is go read the tests, because that's going to tell you what's going on. And they can actually use those tests to step through the code and see how it works. Super big benefit. So the process, and this is sort of a famous saying in unit testing geeking out circles, red, green, refactor. So first, write the failing test. Next, make the test pass, and then enhance the code, start adding a few more things. And then I've got that foundation. I'm building that foundation all the way along. If you want to read in excruciating detail about this unit testing process, I recommend this book. One of the best books I've read on unit testing. This particular one has examples in C#, but super easy to extrapolate. I believe he has a third edition that's either come out or is coming out with examples in JavaScript. And the example that I'll be showing you on the subsequent slides comes from his book. So we've adopted his style of unit testing to great effect. In fact, our products today, sort of in contrast to way back when, where we would test manually for 2 months, ship the product, and then spend another 6 months making it stable. Our products today are more stable right out of the gate than those products were after 6 months. It's a pretty stark contrast. Okay, so let's see what it looks like uh, in code. So again, this is a little bit technical for you non-technical folks. I'll see if I can help you follow along. So I'm writing this procedure called isValid log file name. And this is the code I'm writing at the very beginning. So it's just going to return false. It's doing nothing. So this is important. I do need to write a little bit of code before I can write the test. So it's actually not truly write the failing unit test and then write a little bit of code. I need to write at least some code to get this code to compile. I need this procedure to exist before I can write a unit test that's going to execute this procedure. But again, I'm just hard coding this return false. So I have no logic. And then this is going to be what allows me to verify that the test does in fact fail. So here's my failing unit test. A few different pieces here. One is the name of the test is using a very specific format. So it's the unit of work, or what is it that I'm testing? In this case, is valid log file name. The scenario that I'm testing. So in this case, I want to give it what I expect is a good extension, and then I expect it to return true. So I'm going to go ahead and leverage this test to just give me that starting point. And again, we expect this to fail because that procedure is now just hard-coded to return false. One other piece of this, each of the tests that I write are going to be divided up into three different very distinct sections. One is what we call a range. This is sort of setting things up. In this case, I need to create a new log analyzer so I can test it. The next is act. I'm going to actually exercise that code. I'm going to stimulate that code in some way to get an outcome. And then I'm going to assert. And assert essentially means I want to make sure that this condition is in fact what I expect. In this case, I'm asserting that it is in fact true, that it's giving me back that reaction. In our case, we typically write comments, arrange, act, assert, just to kind of reinforce all the time that this is how we want to organize our tests. So now I'm going to run it and see what happens. So using my tool, this happens to be an example from Visual Studio. I'm going to go ahead and click run. And then the test runner is going to give me a result. And so it indicates up here that the test failed. And now I can see I was expecting true. If things are working, it should be true, but it was in fact false, which I can see here. Great. The test failed. That is what I in fact expected. So now I'm going to write just enough code to make it pass. I'm going to go ahead and add this little test here, which means that I don't like that one. Otherwise, I'm going to return true. The style of this, you may or may not agree with. I tend to return true inside here, return false here. But the point is that this is very little code. I'm not trying to write the whole procedure right now. I'm just focusing on this one test that I'm doing. So now what I'm going to do is go ahead and run it. I can see that it passes. And there's my passing test. So red, green, and now I can refactor. I might need to clean it up a little bit. I might need to add some comments, make it more efficient. I might have written sort of a dumb algorithm just to get it working. And now I might need to tune that algorithm a little bit. Or maybe I've used some dummy variable names and now I need to make them better, etc. So that's how it works. Red, green, refactor. So next, let me talk very briefly about what do we unit test? Do I have to test every single line of code? Well, I said earlier that it's really not about the lines of code, it's more about the scenarios. So some good targets are anything that has logic, where it's going to branch through the code, if, else, switch, etc., try, catch, anything that has anything to do with a calculation. Good example is I'm calculating taxes for an e-commerce application. Pretty important that I get those calculations tested. And then the other thing is calls to other code. If I expect that this procedure is going to do something and then it's going to save something to the database, I probably should make sure that it's actually going to save. Because otherwise, if it doesn't save, that's a kind of a big problem. I'd want to detect that. Some things that you may not need to look at, automatic properties. in C# and some other languages where it's literally automatic code. It doesn't have any implementation that I've written. Other code with no logic or calculations, other libraries that I might have brought in, and they have their own unit tests in the open source library. I don't need to be testing other people's code. I am, of course, making the assumption that they have their own unit tests. And then other code that just has no logic, no calculations. There is some other code that oftentimes is very difficult to test. Some bootstrap code, which is just kind of getting the application spun up. A lot of times that's sort of feathered into the framework that I'm using from a coding perspective, and it's really hard to rip the code out and be able to unit test that. So there may be some aspects of that, that startup code that I really can't test. I might need to use other techniques such as code inspection to kind of look through it and make sure it looks right. And then the good news about bootstrap code is if it's messed up, usually the product won't start, or some aspect of the application just simply won't work at all and would be detected in a smoke test. But I would probably take a look at that startup code and think about, all right, if any of this startup code didn't work, what would happen? And it's usually can't talk to the database, can't talk to this third-party library, et cetera. And of course, product doesn't start. That's a pretty obvious one. So unit tests are great if I rely on my developers to manually run them all the time. And at minimum, we like our developers to run the unit tests before they commit any new code, just to make sure they haven't broken anything. But then we have that reliance back on the human, the imperfect human that we all are. So that brings us to continuous integration. What this does is it automatically runs our unit tests all the time, every time new code is committed into the central code repository. So it's going to wait for new code. As soon as new code comes in, it says, I've got a job. I'm going to go get that code. I'm going to build the product. I'm going to run all of the unit tests. And then I'm going to summarize the results. And most important, if something fails, I'm going to notify everybody. Usually it's via email or a Slack channel or Teams, et cetera, whatever chat program you might use. Our rule is if any unit test breaks, the product is not potentially shippable. It's broken. All right, so by definition, I can't ship it. Unless for some reason that unit test is not applicable any longer. It's pencils down. All right, who's going to get on this? I'll take it. Okay, great. The rest of us will charge ahead. That person who volunteered will focus on nothing else until they resolve that issue, commit the fix, and things are charging ahead. And another thing to be really careful about is if you find out that you need to change the test to make it pass, you might want to take a hard look at that. Maybe even grab another developer and look at it together. Are we sure that we need to change the test? Are we going to change the test and actually just mask a problem? Sometimes you have to change a test, but more often than not, you need to take a look at what the code is doing and make an adjustment there. Okay, so let's talk about automated integration tests. There is a balance here between both, and I alluded to it earlier. Unit testing, again, comprehensive, every single scenario in the system, and we want all significant code. And when I say significant code, I mean logic, calculations, et cetera. Integration testing, in contrast, is typically going to be more of the smoke test variety and only those key workflows. So the key things that need to work. If I was building the next Amazon killer, I probably would want to test, well, I can go to the catalog, I can add a product or two to the cart, I can check out, I'm going to verify that I got an email confirming my order, I verified that the credit card processing worked, and I verified that the notification was sent over to the shipping department to make sure that they have that, and then maybe I can see my order when I go and look at my orders when I log in. What I wouldn't want to try to test with integration testing is I'm going to test all of the city, county, state, and country-based taxes for everywhere in the world, because that's going to be extraordinarily difficult. And that's a perfect thing that unit tests can handle. Perfectly suited for unit tests. They're happy all day long, testing all different combinations of everything, all possible scenarios. And I have a foundation. If I have my unit tests written correctly in that example, they're testing all 168,000 different possible combinations of taxes. And I know that that's happening. I don't need to repeat that. I might want to make sure that when I do have a tax, it shows the tax on the screen. And when I don't have a tax, it hides the text on the screen when I'm checking out. That might be something that I want to do. But that's 2 out of 168,000, right? No tax, some tax. So that's sort of the difference between the approaches with unit versus integration testing. So some things that I shouldn't cover. Again, the tax example is really that every possible scenario. I want to focus on those key workflows, particularly those that if it doesn't work, it's just not going to happen, meaning the product is simply not working and the user is going to be extraordinarily unhappy. So this is sort of a recap of what I just outlined. So integration testing can come in 2 forms. There's probably a bunch of different forms, but 2 main forms. One is user interface driven testing, where it's sort of robotic testing. It's popping open the UI, it's actually typing things in, clicking buttons, and then testing everything from the user interface all the way down to the database and the web services, et cetera. And then there's API driven testing, particularly today, where we have applications that are oftentimes just separated out into what's running in the browser and what's running back behind the scenes. Being able to test the behind the scenes piece is important. That doesn't get me away from testing the UI. So just going through these points here, the UI driven testing can be a bit of a pain. It can be a little brittle, like I said, kind of expensive to do. There is certainly a benefit to minimizing that UI driven testing if I can help it. So again, it's a common theme here, unit testing, that's your foundation. And then the API driven testing that can test what that user interface is consuming on the back end. But you don't want to throw out UI driven testing. At least having a sanity check that's stimulating that user interface is important. And again, you're still going to have the manual smoke test, just looking at the product, making sure that something that can be difficult or even more brittle to detect, let's just make sure that the UI generally still looks right, make sure that no weird font happened or some style sheet gets screwed up where now all the text is this big and it's covering stuff up, etc. So that sort of sanity check is important. And that's what I'll talk about next. So where does manual testing fit in? It still has a seat at the table. So it's not going to go away. The automation you can think of as your safety net. That's the thing that lets you sleep at night, knowing that every aspect of the product is being tested using the unit tests. The key integration points are being tested via the automated integration tests. But you still need to get in there. You still need to open up the application, take a look at it, and at least go through those basic scenarios. So when do we want to test manually? And I touched on this a little bit earlier. First of all, big believer in the developers stepping through their code to make sure they actually see that their code is working. I want to test news stories in the sprint. And the way that we look at it is the development team, which is part of the Scrum team. So Scrum team, product owner, Scrum master, development team, for building and testing the application and getting it ready for the product owner to review. And then the product owner accepts or rejects the work of the team. So the product owner is doing manual testing. They're not doing all of the scenarios that the team might do to validate that. So when do I want to test manually? Definitely before a new release. And this is that sanity check that I talked about. And this is a rule of thumb that I use. Folks have asked me, hey, we're doing about 40 hours of manual testing with each new release. Is that appropriate? And I say, nope. This is my very unscientific rule of thumb. And it really drives to 2 key points. One is you're not just going in there and banging on it for 5 minutes, but you shouldn't be spending 3 days. If you're spending 3 days, that's an indication that the rest of your quality strategy needs some work. And by the way, if you are spending 40 hours on manual testing, this isn't just, I'm going to decide not to do that, and then next week you're spending 2 to 4 hours. It might take some work to evolve to the point where you can, in fact, only test for 2 to 4 hours. So this is my, again, unscientific rule of thumb. One person sitting down at the computer, no more than 2 to 4 hours, and oftentimes less. A lot of our smoke tests, as we get closer to production, can be done in actually even less time, focused on those critical workflows. If all the pieces are working correctly, if the strategy is comprehensive, it's going to allow you to meet this standard. Okay, so putting it all together, these are the 10 things that our teams do all sprints, all the time. Acceptance criteria, these acceptance tests, the behavior-driven development style test plans, developer testing, automated unit tests, continuous integration, manual acceptance testing, which is executing those acceptance tests manually, writing select automated integration tests, code reviews. Again, it wasn't the topic today, but those code reviews, super important. And the product owner review. And then finally, when we are deploying to production-like environments, going through staging, pre-release, release, et cetera, doing that manual smoke testing just to kick the tires and make sure it's all working together. So what are the key takeaways for today? First, it's really expensive to have crappy software. It's going to hit you all day, every day in all kinds of different aspects. It's not free. Again, there is an investment here, but it's an investment, not an expense. And it is going to speed you up overall. The testing itself is only part of the picture. Remember those 7 habits that I talked about? Being able to inspect those requirements, super important. And this is a metric here about those code inspections. Some studies showed that you can detect bugs in 1/4 of the time if you do a careful code inspection as compared to testing. So super important that you're doing those code reviews and code inspections. Comprehensive coverage with the unit tests, integration tests for those key workflows. And then again, manual testing, still super important, but it's much more during the initial development as opposed to trying to test absolutely everything all the time using those manual tests. So I actually write quite a bit about quality in my book. Here's a little reading assignment that you can read about all of these concepts in much more detail. And finally, we're on to questions.
Thanks, Dave. That was a great presentation. A lot of information there. We do have quite a few questions. Again, we're willing to stay on as long as it takes to answer all the questions. If you need to drop off, we'll get the link out to you with a copy of the recording slides. I see that you've all figured out how to use the like button, so that's great. We have some upvoted. So let's dive in. Are you ready, Dave?
I'm ready.
Great.
Bring it on.
All right, the first one. Currently, unit testing is the domain of the developers and outside the control of QA. Is this typical? Are you recommending that QA assume the responsibility of writing unit tests?
Yeah, I know that in some organizations, QA helps with unit testing. I think that's a bad approach. What I think the risk is that it abdicates the developer from being or feeding that unit test authoring process into their development lifecycle. If you're doing test-driven development, by definition, it has to be the developer, right? Because writing that test first, forcing the developer to think through the design of that procedure that they're writing, that's a super important part of the process. So I think it would be a mistake to kind of toss over the fence, even if the QA person is embedded in the Scrum team, which I certainly would recommend. Tossing it over the fence off the developer's plate onto QA, I think would be a mistake. Now, I realize that some QA folks are also developers on the team. In that case, they would be writing unit tests for their own code, but I would not separate the unit testing from the developer's responsibility.
Great. Next, our product is developed in C#. Our QA team writes our automated tests in Python. Do you recommend writing automated tests in the same language as the product? If not, which language would you suggest?
So I'm assuming for a minute that these automated tests are automated integration tests as opposed to automated unit tests. I think my personal feeling is it doesn't matter. Our teams, if they're writing automated integration tests that are testing APIs, they are typically writing code in C# because it's all in the same code base. It might be in a separate project, but it's all in the sort of in the same spot. If they're writing automated tests that are, for example, stimulating the user interface and they're written in Python or any other tooling, there's lots of tooling out there. It probably doesn't matter. Even if they're kind of touching the API directly for those integration tests, I don't think it matters. Where I think you might want to think about whether or not this is a challenge is the nature of your team that only one or two people know Python and the rest of the team knows C# and there's no crosstalk, because that might hamper you a little bit. We're a big believer in cross-functional teams, which means that we certainly play favorites, right? This is the back end person, this is the front end person, that's their specialty. However, the front end person can dive in and help out on the back end. The back end person can dive in and help out on the front end. So again, they're not the only person that can do that. It's just we do have the best person to do that. What happens, for example, if on the team, the person who's writing the Python tests falls behind a little bit and we're threatening getting that sprint done, getting all those user stories done. In an extreme, if I just have one person that knows Python and 5 other people that know C#, that might be a challenge. Now, that probably doesn't mean you want to throw out a bunch of Python code that you've been writing and maintaining. What it might mean is just making sure that those C# folks start coming up to speed with that. So I think it's less about the particular languages and more about ensuring that you're not creating little islands of capability where, in worst case, person gets sick, person wins the lottery, person goes on vacation for 2 weeks. You don't want to be stuck. So I just would want to make sure that those cross-functional, that cross-functional concept is important. And then it's working for you. I'm a big believer in outcomes. I like to joke. I wrote a 500-page book on process, right, about Scrum. One of my favorite quotes is, "Don't let the process get in the way of progress." Right? If this is working and it's working well, and you guys are cranking out high-quality software and you're reliably getting those automated tests done, keep on trucking.
Great advice. All right, next one up. We are currently running a lot of manual tests because our legacy code doesn't have good unit test coverage. How can we reduce the man hours spent on this?
Yeah, a couple of things you can do here. We ran into this at a client recently. We were adding, we built a new microservice in the cloud, and then we added some code to the legacy product to call out to that microservice. As we got into the guts of that legacy product, we realized it wasn't architected to be unit testable. All the dependencies were kind of tied right into each other. So what we did is first off, we made sure that any new code we wrote was kind of separated over here in another part of that legacy product. And that part we architected for testability. We made sure that we could write unit tests against that new part. And then we had some code in select places in the legacy code that called out to our brand new code. So I think the first thing is make sure you're stopping the bleeding. Any new code that you're writing in your legacy product, try to figure out how to isolate the new logic as much as you can into sort of a fresh area, and then you've got the old area, and then everything in the fresh area is you should apply a very specific and pretty stringent standard, which has to have full unit test coverage and has to actually work. The other thing you can do is you can start looking at the manual tests and figure out, do you have any sort of 80-20 rule? Do you have any indication that 80% of the code is covered by 20% of the unit tests? Is there any way that you can backfill either some automated integration tests or backfill some automated unit tests that will start eliminating those manual tests? For example, and it's not as much 80% of the tests, it's 80% of the time. You might have just a handful of tests that take a heck of a long time to do manually. Maybe you've got to do a bunch of setup manually. Maybe they're super brittle, and then you got to do a bunch of tear down and clean up manually. Maybe you can do a little bit of analysis of where you're spending that time. So I think I would combine those two things. Stop the bleeding, figure out how to write unit testable code going forward if you can, and then do a little bit of sort of analysis around the manual tests. The other thing you can do is figure out, well, what are the manual tests that have been highly likely to detect bugs, and make sure that you're definitely focusing on those. And then look at the other tests and figure out, is there any way that we can streamline these? And again, start feeding in some integration tests, or automated integration tests rather.
Excellent. All right. Is it a bad thing that there is a separate testing team from the developers? We currently have developers focused on fixing bugs and writing code.
Yeah, so it sounds like you might be doing Scrum, but you're doing Scrum, but you have people that aren't on the team that are actually driving that product increment to done. My sense, I don't know a lot about what's, exactly what the mechanics are there, Thomas, at your company, but I would think if they're not on the same team, it would be extraordinarily difficult to orchestrate writing code and testing it and fixing all the bugs in the same sprint. So a lot of times what happens is that you write the tests and you're fixing bugs, and then you're tossing it over the fence, and then the testing team is testing it the next sprint. What you're doing is actually mini waterfall. You have to design, code, test, fix bugs, and the product owner needs to accept the product all in the same sprint. So by definition, if your product owner is not looking at fully tested code where all the bugs have been fixed, then they're actually not accepting anything. And in fact, your Scrum team is getting nothing done. So that's a pretty harsh way of looking at it, but that's going to, if you can hammer that out, if you can actually fold the testing in to the development team and have them fixing bugs and writing the code all in the same sprint, then I think what you'll see is you'll get an acceleration of time, and you'll actually get more predictability from a schedule perspective.
All right. Next from Stephen. Should you test both positive and negative results? You have tested valid log file names, but no negative. What about null pointer handling, etc.?
Absolutely. So this is another part of why having the developer doing the unit testing is so important. They can think about those things. And by the way, that's also why code inspections are so important. When you're doing code inspections or code reviews, you're not just looking at the implementation, you're looking at the unit tests. You should be reviewing the unit test code as carefully as reviewing the implementation. In fact, when I do a code review, I review the unit tests first, because it both allows me to understand what the implementation expectation is in terms of behavior, but it also allows me to carefully read through it, and I might kind of have a head scratching moment and thinking, how does this test actually work? And it also helps me identify missing scenarios. That's also what's really nice about that naming convention that I showed you. And I know my example was super simple. It didn't handle everything comprehensively. Because what's going to happen is all the tests for a specific procedure are going to be sorted together in the list alphabetically. So you can actually see all of the scenarios that procedure is being tested against. So you can very quickly see if, well, wait a minute, what if, I've got this negative test? So absolutely, both positive and negative, anything I can do to exercise that code, and then ensure I exercise all the code paths.
Great. Are there any recommended test tools that one could use?
Yeah, so I listed a few on that slide. When you guys get the slide deck, you can check those out. We do a lot of C#, and we do a lot of JavaScript. So we're using the usual suspects. We tend to like ReSharper in Visual Studio land. Has some great tooling, both in terms of test running, code coverage, things like that. Jasmine and Karma in the Angular land, and the usual suspects in different other JavaScript libraries. So usually what we pick in any particular technology is what's most popular. And typically what you do is, if you're adopting a new technology, looking through the documentation of that technology and seeing what testing they recommend or have built into that framework.
All right, great. How should we tackle code that doesn't currently have unit tests?
So I hit on that a little bit. The other thing I would do is I would pick up a copy of The Art of Unit Testing, because he actually spends a chapter or two talking about how do I deal with legacy code. And at a very high level, it's you start chipping away at it. Stop the bleeding. So new code that you write, figure out how to separate that new code as much as possible, and then have the old code just call into that new code. And then you can start chipping away at refactoring that old code. Now, typically you would do that for maybe some of the most critical code in the application. Maybe you do that for code in the application that seems to generate the generate the most amount of bugs and that sort of thing.
All right, up next. Our test reports usually return good results, but we still find bugs in production. Do you have suggestions for how we can go about improving our testing strategy?
Yeah, don't you hate that? We do all this work and then we still find bugs. We do a couple things. First of all, our rule is very similar to writing a failing unit test before writing new code. We write a failing unit test before fixing any bug. So we guarantee that that bug will never come back. And the reason we do that before fixing the bug is to guarantee, just like writing the test before writing the code, we guarantee that that test will fail when the bug is present. So we write the unit test that would have detected that bug. We then fix the bug and make sure that the test passes. So it's a little bit of a red-green sort of approach. If you have a situation where it's impossible to unit test that particular piece of code, then I would look at, again, can I start to pull that code out and make it unit testable by doing some refactoring? Or can I add an automated integration test that would detect that particular bug? Besides that, it's probably taking a look at, is there any other reason why we're missing this? The big thing that I'd be looking at is, are you finding bugs in production in new code that you're writing? And then I'd probably be looking at things like, am I doing the right code reviews? Am I carefully reviewing the unit tests? The other thing that we've done in the past with particularly tricky code is we've actually brainstormed test scenarios together. So we've actually just listed out, here's all the titles of the unit tests that we would expect to write. And then one of the developers just takes that on and writes all the unit tests. So I do a little bit of kind of putting ourselves under the microscope on that one.
Great. All right. From Bryce, if it is not possible for the developers to write the unit tests, is the next best solution for our software testers to create unit tests alongside the developers?
Well, to me, that's a little bit of a smell. And maybe Bryce, you can we can follow up on this a little bit more if you reach out to me on LinkedIn, but that's a little bit of a smell. I would wonder, why is it not possible for developers to write unit tests? That to me feels like there might be either a technology gap, they don't have access to the unit test framework, or it's a knowledge gap. They don't understand how to write unit tests. So I think it's a little bit of a disempowerment if your developers cannot possibly write unit tests. I think my sense is that you're probably losing money and losing flexibility by having a dependency on software testers. So that would be my sense. And you're certainly not doing test-driven development, or it would be very difficult to do test-driven development because software tester would have to write the test, and then 13 seconds later, the developer would have to write the code. So I would want to pick at that further. And again, more than happy to jump on a phone call and talk more about that, but that might be a little bit beyond the scope of today.
All right, next one up. What are your thoughts on regression testing and automation approaches?
Sure. So regression testing, I think there's a few different definitions of regression testing. I think the one that I have in mind is probably an oversimplification. Regression testing is testing anything I didn't write this sprint, right? Anything that was completed in some sprint from just the last one to the beginning of time of this product is regression testing. That comes back to the strategy, the foundation of quality being automated unit tests. If I have the privilege of writing a product, in the last few years, starting in the last few years, and I've built in the appropriate unit testing, my product is regression tested multiple times a day. Every time there's a commit, the entire product is tested. Next commit an hour later, entire product is tested. So again, I would fall back to the automated unit testing being the foundation of that regression testing approach. And then, like I said, the integration testing or exercising a smaller subset of the product.
All right, next one from Todd. Hi, Todd. How are UI testing and end-to-end testing related if you can't isolate to do integration or unit tests?
Yeah, so end-to-end essentially means, to me, from the touch of the user to the last touch of the software. Typically, it's something from the user interface all the way down to the database or all the way down to a web service. So UI testing, there may be end-to-end testing if my interface is an API. So that could be if I'm creating an API for consumption by another system, by definition, that is the user interface. The user is just another system. So I can do end-to-end testing of an API. If there is a user interface that's placed on top of that API, now UI testing, if it's truly end-to-end, it would be from the UI all the way down to the bottom. Depending on the nature of your product, that UI testing, you may decide that that's simply going to be manual testing, because I'm going to exercise the heck out of that API call or the API that's being called by the UI to make sure that everything is working as it should be from an integration standpoint. Remember that also in the front end, in today's contemporary front ends, I can write unit tests there. That's something I didn't mention. I should absolutely be writing back-end unit tests in the Java code or the C# code or the Node.js code in TypeScript or JavaScript. I should also be writing unit tests in the front end. If my front end isn't unit tested, then by definition, I'm missing a bunch of scenarios. So unit test anything that the technology supports it, even if it means you're going to need to think a little bit more deeply about the architecture of your code. So if you can't isolate to do integration or unit tests, I would think about, can I make sure that, again, the new code that I'm writing allows me to do that. But you should be able to do some sort of integration testing, even if it means you're stimulating things from the UI. And then again, be thinking about, are there ways that I can minimize my exposure on the UI side of things?
Great. All right, next up, which test automation do you recommend? Which automation tools are used in Silicon Valley companies such as Facebook, Amazon, et cetera?
Yeah, so I talked a little bit about this one earlier. I haven't dug into what Facebook and Amazon use. I would imagine a Google search would dig something up. They're obviously testing at a scale that's unlike most of us would ever need to see. And they've brought it to an entirely new level, by the way. I don't know if you know this, but companies like Amazon, they deploy new code thousands of times a day. Why? Because they have a level of automation that most of us would just dream of. So my guess is it's probably a combination of many different tools, plus probably some homegrown tools and frameworks that they use. But we have access to a lot of the same frameworks that they use, particularly Facebook, which has exposed different frameworks. But again, like I said earlier, I think it's going to be looking at the frameworks that you're using, looking at what's most popular. We like most popular because if I have a question and I need to get some support, I can usually go on Stack Overflow or do just a Google search and find some help. If I'm using some esoteric tool that some guy wrote and has 1,000 people using it, that might be a little bit more difficult for me to get the community support that I want.
Oh, did I do the wrong one? I think
I think
just
that was a
missed
duplicate.
another. Okay. All right. From Jerry, do your teams use feature flags or feature toggles, and any lessons you've learned from using them?
We do very selectively. I know some teams use feature flags and feature toggles extensively. We use them when we have a feature that can't be completed within the confines of the release lifecycle. And these, we're typically working on products where, unlike Amazon, they're not being released 1,000 times per day. They're typically being released after several sprints, based mostly on the customers. Customers don't want a new version 14 times a month. They may want a new version every month or two. So typically we would use a feature flag or a feature toggle when there's a partially completed feature that's not ready for prime time. And because that feature is being built in user stories, we're driving each user story to done throughout each sprint, but then the product owner wants to ship. We may need to turn something off. The other time we've used a feature flag or a feature toggle is when the customer doesn't want to expose, when our client doesn't want to expose to their customers a particular feature quite yet, or they may want to actually turn that on or off on a per customer basis, in which case it's a little bit more of a configuration setting as opposed to a feature flag or a feature toggle.
All right, looks like we are down to the last one. My company decides to assign the implementation to a supplier. How can I check if they have set unit tests in the code, and is there some best practices to perform testing once they release a sprint?
Absolutely. So we, I think, are one of those suppliers of which you speak. What I would, if I was a client of Ascendals, what I would expect is that I should be able to ask for and see during a sprint review. Can you guys show me the last unit test run? And they should be able to pop up on their screen their framework that shows that, all right, maybe I'm just a few sprints in, and they have 469 tests were executed in 28.2 seconds, and all of them passed. And then I might want to drill into some of those. The other thing I might ask for is, can you show me a code coverage report? And code coverage is not just about the percent of code that's covered, it's the percent of the logic that's covered. So depending on your level of technical aptitude, you may want to dig in and see that. So what I would do is I would actually ask, for a technical review in addition to a sprint review. Now, if you're paying the supplier, they may ask that, all right, well, this might cost you a little bit more, or it might slow us down a little bit because we need to spend some time with you. It really shouldn't be a big deal. I'm talking about 1 hour, maybe every other sprint. But they should absolutely be able to say, sure, no problem. I'll step you through whatever you want. What I would be looking for is step me through. Thank you, Jerry. You're very welcome. I'd want them to step me through the code, show me some unit tests, not everything. Show me some unit tests, show me the code coverage for a couple of different classes. What that does is it tells you a couple things. One, do they actually know about these techniques? Are they in fact writing unit tests? Are they actually doing code coverage analysis? Do they know how these tools work? If you start asking those questions and they kind of stumble a little bit, or say, what do you mean code coverage? Or, oh, I don't know if I can show you that. Well, why? Why would you not be able to show me that? If any of our clients asked us for that, we can get on in 5 minutes and show them. We're looking at that stuff all the time, right? So we're going to expect that that person's fairly technical, but we can pop open our tooling and we can show you the tests. I can explain to you how they work. I can show you some examples, show you the code coverage analysis, show you the code that we're not trying to cover with unit tests and why, talk about the architecture, dependency injection, the isolation framework that we're using. Every answer should be like this. Now, it might be that you need to talk to maybe one of the more senior technical people on the team. If you've got some junior developers, they may not understand absolutely everything from all the tooling that's going on, but certainly the senior people on the team should be able to answer those questions with no problem whatsoever. And I would encourage you to ask those sorts of questions, particularly with a new supplier. You want a level of comfort that they absolutely are doing the right thing and they know what they're doing. Thank you, Maura.
All right, I think we have answered all of the questions. You guys have been a great audience today. Not only did most of you stay on until the bitter end, but you had, I think, the most questions that we've ever had. So kudos to you, and thank you again for attending. Thank you, Dave, for sharing your deep knowledge and expertise with us today.
My pleasure.
And everyone have a great day. Like I said, we will get the link to the recording and slides out to you. Thanks again.